Well, hello everyone. Welcome back to Adrian's Digital Basement. Who's ready for a little bit more Atari 8-bit computer troubleshooting and repair? I am, and I have another machine to fix. This is an 800XL, which in the second channel video where I tested all the machines, this one didn't work. I said black screen, no activity, and PAL. So in this video, I want to try to figure out what's wrong with this thing and hopefully get it working. So without further ado, let's get right to it. The last Atari repair video took a very long time, and let's hope that this one is much faster. So it's a regular 800XL. It's in pretty rough shape. Keyboard looks bad. Like, notice how keys are cattywampus, they're turned. This keyboard feels very bindy. In fact, the K key gets stuck, but when you push the keys on the edges, it feels terrible to type on. Funny thing is, as bad and bindy as the keys are, they aren't as mushy as some of the 800XL keyboards that I've seen. And so that has me wondering, what's going on? Wow, I cannot get that keycap off. It just refuses to come off. And the keyboard has a lot of flex in it as well. See that? Okay, I don't understand what's happening. I'm pulling with as much force as I possibly can. And like, notice the I key, it's like twisted now. What happened? So I think the switches might be pulling apart, something like that. I'm not sure. All right, I already took the screws out of this thing, and oh, it looks like the keyboard is already detached. Mechanical keyboard though. We have a PCB. There is, oddly enough, a little spring clip here. What does that do? Is that for ground? I don't understand where that pokes. And that could be causing a short, who knows? But it looks like it's something to do with grounding between cartridge slot and the keyboard frame. Bubble wrap on the flaky ribbon cable. Very unusual. All right, well, inside the machine, it's dirty, but obviously we don't have any missing ICs, and that was one of my concerns. On first appearance, everything is accounted for, but to be honest, our black screen could have been caused by bad connections in these sockets, just judging how dirty everything is. I'm not familiar enough with Atari's chipset to be able to tell which chip is which, except this is a 6520 as it's labeled as such. And you know what? We might have found our issue. We got MT RAM in here. There is one non-MT RAM chip, MOSTEC. The rest are MT RAM from 1987, 30th week. Now in North America, most of these would have RF shielding that would be around this silver area, I think on the top and the bottom. But I'm not really seeing the telltale signs of that having been the case on this machine. This is a PAL machine, so it came from a different region. And that FCC shielding wasn't always there on some of the overseas markets. So to get this out, it's a bit of a trick. You kind of have to wedge it out of the case on that corner. And I'm sure there's some kind of a trick that I haven't learned. Ah, that just scratched me. Oh, there's the bottom of the board. Oh, we got some bodges here. Look at this. Well, one bodge. Definite rework. That's been reworked as well, which I think that was in a socket. Yes, it was. So that was swapped out at some point by someone. That looks like it's been reworked. Is it just that everything that's in sockets has been, well, I don't know, hand soldered at some point? Maybe. I don't know if that was a repair done at some point, or if this machine was just partially made, maybe they ran out of chips and then they installed the sockets by hand and put the ICs in. Looks like water has dripped into the case at some point and washed away some of the dust. It's kind of interesting. For identifying the ICs, I found this handy parts list on Atari Age, and I printed it out for myself, so double-sided printout listing all the chips. So let me identify what's what, just to help speed up the diagnostic process. So the C012294, that's the Pokey. C014806, that's Sally, CPU. Feels like water has dripped onto this IC. C021698, that would be PAL Antic B. And that must mean that this is the PAL G TIA chip. C014889, Yes, that is the PAL GTIA. Now there's another PAL Antic, but it's got a lower number. So this one was what, Rev B, I think? Yeah, dash B, whatever that means. This little IC, the socket C061618. 61618 MMU. So this machine has 64 kilobytes of RAM and it requires a memory management unit to do some bank swapping, and I assume that's what this chip is. The ROM chips have Atari part numbers on them, but those don't seem to be on this parts list. Time to plug this in, verify that it's still not working, and then once that's done, we can proceed with further diagnostics. So if I recall, this gave us a black screen. There's the black screen. And you can tell by the input vertical frequency, 49.86 hertz, that this is a PAL machine. I mean, we know that it's got PAL video chips in it, so that makes sense. But at least the crystal oscillator is correct. Otherwise, I think we would have random garbage on screen right now. All right, so I think first off, I'm just going to push down on all the chips and sockets. And let's see if that somehow fixes the machine. I mean, this is the easiest first step of troubleshooting, obviously. I really don't think this is going to make it work. No, it did not. Okay, so next up, are any of the RAM chips getting warm? No, they are not. But empty RAM chips, when they go bad, they don't typically fail in a way that makes them feel very hot. Now, from my understanding with the ROMs on Atari machines, on the original 400, 800, there are 3 chips. 2 of them are operating system ROMs, and 1 of them is like a math library ROM or floating point ROM. And I wonder if this smaller one is that, and the OS is contained on this single larger chip. When I was doing testing on the 400 that I repaired recently, I figured out that I could take out the Pokey, I could take out the 6520, and I could take out the math ROM chip, and the computer still would function properly. So I can't take out the Pokey or the 6520 since those are soldered in. But I'll remove this smaller ROM, which I assume is the math library. I should probably look up that part number just to make sure. Let's just see if that made any difference. Nope, it did not. Now, if this ROM chip had gone bad, it could totally trash the data bus and the address bus, which would keep the computer from booting, and you would definitely get a black screen. I really couldn't read the markings on that IC, so I used my phone camera. It's C060302A. And it appears, after doing a little bit of Googling, that this is the basic ROM, which is now built into the XL line of computers. And it is this ROM that contains the OS, so 16 kilobytes, and this is an 8 kilobyte chip. Don't know if the computer can operate without this. It definitely won't do anything without that chip, though. In fact, I am really curious to test that by popping out the ROM chip, specifically to see what happens if we even get a video signal. Because I don't know if I tested that on the 400. Oh, we get kind of a brown screen. And upon power cycle, it's still brown. I wasn't sure we get anything. I was under the impression that without the OS ROM, the GTIA is not really programmed properly and you don't get any good video, but that looked like stable video. It just was kind of brown. And putting the ROM back in, I think we're going to get a black screen again. And we do. So it feels like it's initializing to some extent, just a little bit. So I think this is actually a good time to try out the Super Salt cartridge. Now I know this is for the 600 and the 800, so it's not even for this machine, but it seemed to be able to kind of work even though we had bad RAM when I was testing it on the 400. Now, judging by how dirty this is, I bet you the cartridge slot is bad, so I'm gonna hit it with compressed air and then contact cleaner. And incidentally, with compressed air, I have one of these battery-powered ones, and while these are useful, they're not nearly as good as this because I can get down into the crack and really target the air. This just blows air all over the board, which will just blow a big cloud of dust all over the basement here. And then I'm going to use some of this QD electric cleaner, which sprayed all over the place. I'm going to insert this basic cartridge that actually has gold contacts on it first, just to kind of work the cartridge slot a few times. And I'm doing that because these PCBs don't have gold coating or gold contacts. They don't really make great contact into slots. So that's probably good enough there. Okay, so this has to go this way with the sticker that says cartridge label side facing me. Okay, the idea is if this can work at all, hopefully we'll see something different on screen and maybe it'll give us a good tip as to what the problem is. I will need the keyboard to navigate this cartridge. Black screen. Okay, so a dead test, this cartridge is not. Now keep in mind, I haven't even done basic troubleshooting yet. We haven't checked the voltages. I'm sure those are fine because I'm using an external 5-volt power supply, but we haven't checked the clocks. We haven't checked the reset signals. That's probably all stuff that should happen. So I am going to clip onto Sally, just move the clip back and forth, make sure it's got contact on the pins. I did a quick Google search for Sally pinout and I found something on Atari Age. I think everyone knows the drill at this point if you watch my videos. So we got to check the 5-volt rail. So I'm clipped onto pin number 1. Okay, V in is not really reading anything. Yeah, I mean, the CPU is running. So clearly whatever V in is not the actual 5 volts because it's outputting stuff. So pin 8, V out, that's showing a good 5 volts. So let's assume that's the VCC pin. Sure. Let's go 1 pin over to the sync pin. And I know if the CPU is halted, I don't think this pin is doing anything. So it does look like the CPU is currently executing code, which implies the reset line is working. And I'm on the reset pin. That's pretty noisy, isn't it? Let's turn the computer off. And when I turn it on, you should hear the click of the power switch. And there should be a momentary pause before that line goes up to 5 volts. Yep. Okay, that's a good reset. It's noisy, but it's good enough. We'll just do it one more time. Click. There we go. Goes high. Right. Next up is the clock input. 1.77 megahertz. Now on the 400, I saw a bunch of pauses in the clock signal, and I don't see that here. Let's turn the computer off and on real quick. Yeah, it just instantly looks good. So that was pin 3. Pin 37, that looks good as well. If I zoom in, it'll have the actual frequency. This is the halt pin. Now this is a different processor than the 6502 that was on the 400 we diagnosed last time. So maybe on the 400, it slows down the clock to allow other peripherals to take control of the bus. And with this processor, it uses this halt pin. So I'm on pin 9, address line 0. And let's just go through all the address lines and make sure they look good. That one looks good. Yeah, I'd say that's fine. Yep. Good. Good. Every time I say good, I'm on the next line. That looks good. Yep. Totally fine. That's good. I guess that's okay. I mean, it's fine. It just looks different than the other ones, but just depends on what the computer's doing right now. It's obviously running. It's just stuck in some kind of a loop. So that looks fine. That looks fine. And that looks fine. That's the last address line on this side. Address line 11. That looks good. That's 12. Looks good. Looks good. Yep. That looks good. Yeah. And that's address line 15. That's the last one. So the next pin is data line 7. I'd say that looks okay. We're seeing it having excursions all the way to the top, 5 volts and ground. It is a bit weird how we're seeing this angled stuff happening though. So let's keep an eye on that, see if we see that on the other lines. I'm not really familiar with how the data bus looks on Atari 800 XLs. So it could be that that's like that on every line and that's normal, because it is odd how as it rises, there's like pulses in it, but it could be because the data lines were floating at that moment and there might be a weak pull-up on the data bus on this machine. Without having a look at the schematics, I couldn't tell you for sure. So that's data line 7. 6 looks the same. 5, 4, 3, 2, 1, 0. Yeah, they all look exactly the same. Although 0's got some strange stuff happening on this. What's that all about? Not quite familiar enough with Ataris to know what would be good and what's bad. So next pin is read write. I think I lost my place. Let's go down from the clock there. So that's the clock. Then read write. That's totally good. That's the CPU reading and writing from stuff on the bus. That was that halt pin, which we looked at before. And there's another read write pin. I'm not sure I could trust this pinout. Read write twice and the VCC pin's labeled weird. I'm gonna look for another pinout. How about we go right to the source and look for the service manual for this machine? Okay, here it is. This is the Sally. So 21 was VSS and VSS, yeah, so ground and ground. The other one just labeled as V in on the ground pins. There's VCC. We do have a not connected on pin 7. I don't think I even looked at pin 7. But if we look over here, there's only one read-write pin, and 34 is not connected, which makes sense that we didn't really see anything happening on that pin at all. According to this, we have phi 0, phi 2, and we have phi 1. So let's check pin 39 and 37 just to double check. So this is pin 39. That clock looks completely fine. And that is the clock input. That's 37, phi 0. It looks good. And phi 1 we already looked at, and that looks good. Okay, so everything on the CPU I'd say looks pretty good. I'm not sure what's going on with that kind of curvature on the data lines, but because it's on all of them all the same, I'm probably going to go off and say that those are fine. By the way, when I worked on testing all these Atari machines on the second channel video, someone mentioned in the comments that their Atari is channel 3 and 4, and they didn't understand why I kept saying 2 and 3. But even in the service manual here, it says that this Atari 800 uses 2 and 3, the North American one, for tuning in on your television. Most devices seem to use 3 and 4, but for whatever reason Atari, at least the ones I've used, seem to all be 2 and 3. All right, well, the machine is running and we still have the black screen, as you notice. Why don't we try sticking in a game cartridge, one that has good contacts. Here's Miss Pac-Man. I'm not sure this Super Salt cartridge has the best contacts in the world, so we'll try this. Sure, this is just going to give us a black screen. Yeah, so we are getting exactly the same, just a solid black screen. Now, one input I want to check is on the GTIA, there is a oscillator input, and this has to do with the frequency oscillator for the color carrier. I don't know what happens on the Atari if that's missing. There's a separate clock for the CPU, and that's looking okay. And actually, now I think about it, is it the GTI that actually generates the clock output? It does say phi 0, but it also has phi 2 phase 2 input. But let's take a look at pin 28 on the GTIA. Okay, I'm on pin 28. I would expect to see like 4.43 megahertz probably. 3.54. I know this oscilloscope really isn't accurate at measuring frequency, but shouldn't this be the PAL frequency? That sounds like NTSC to me. Now, unfortunately, with the two oscillators, they have Atari part numbers, so I can't really make heads or tails of what frequency those are running at. In the service manual, which I assume this is the one for the NTSC model, it does say the crystal should be 3.579545. And what's sort of amusing is this has both Y1 and Y2 on the board, and the schematics only list Y1 as the crystal oscillator. So maybe Y2 is the 4.43 megahertz for the PAL color carrier. So I found some recreated schematics for the 800XL, and it says change Y1 crystal 3.546 whatever megahertz to different model 3.579545. So there's Y1, note 2. This is the little oscillator section, and that line makes its way the oscillator signal. And there is a PAL signal there. Jumper W2 installed, note 4. I think it said to remove that. Add jumper for domestic. Okay, so for NTSC it's there. It's not super clear to me with these schematics. Is this talking about a PAL board or is this talking about an NTSC board? Yeah, I don't know if these things here need to be installed for an NTSC unit or removed and or swapped around for the PAL units. Oh, but look at that. Y2 is right there with that 4.43. So that's the PAL color carrier. Well, I think without a doubt, this is still a PAL machine. And the reason why I say that is because when I took out the ROM chip, remember we had that brown screen and that was in color. We wouldn't have working color if it weren't for that. We'd have just a monochrome screen. So we know the clocks are probably all good on this. And I'm assuming that the schematics here actually have to do with the PAL machine. All right, so where does that leave us? Well, probably at the minimum, I think I'm gonna give this board a wash because every time I touch it, it makes my hands dirty. And then I touch my mouse and other things on the bench and they all get dirty. So I'll be right back after washing this motherboard. Does that not look 100 times better? Yeah, now I can touch this thing and not get dirty fingers. Awesome. Now cleaning this board didn't really help us in figuring out what's wrong with it though. But before I do any other chip swapping, I think it's time to address the elephant in the room, the MT RAM that's on this board. I'm pretty much gonna default to some or multiple of these being bad. Although actually, you know what? Maybe the first thing I should do before I touch that even is let's just quickly examine this bodge wire on the bottom. I have a hard time believing that this was a factory bodge, just because they would have glued this down if this were a factory mod. Now it appears that this is on pin 17 on the top ROM. I need to figure out which pin that is. That's data line 7, the one that was jumpered. Just gonna make sure all of these are connected together, because you never know if they've ripped something else. Maybe this machine has never worked since that bodge was installed. So far, everything is connected. So this pin on this top ROM, address line 7, that's address line 7. Okay, so this is one of the differences between these two chips. So this is address line 12 that I'm on, and that should be pin 2 here. Yep, it is. Then there's chip select. And then 19 is address line 10, which matches up with the other chip. Okay, so everything looks good on these two chips. That bodge wire appears to be installed correctly, and I don't see any other issues with all the lines going to these two. It's always good to check that stuff because whenever you see rework on the back, you never know if someone did a good job or caused an issue. So I think at this point, it's back to the empty RAM. Now, unfortunately, unless you have something like a dead test cartridge or a diagnostic cartridge you can replace the system ROMs with that doesn't rely on the RAM at all, there's no real way to test it. And the Super Salt cartridge, which we tried already, just gives us a black screen. That means we have nothing else we can really do at this point, except for taking the RAM chips out. Luckily, they're in sockets one by one, and trying them in a RAM tester or another machine. Like I could stick them in a Commodore 64, see if they work there as well. So you probably know the drill by now. I'm just going to pop these out one by one, stick them in the RAM tester, and any that come back as bad, I will mark as such. Well, unfortunately, or fortunately, whichever way you look at it, all the RAM tested good in this tester. The RAM that was on here looked like it was from 1987, and that later MT RAM generally is reliable. I did pop out the socketed ICs and just check and put them back in, make sure there were no bent pins, and there weren't. Did the same for the ROM. And interesting is the ROM socket was obviously a longer socket that someone broke and shortened so it fit on the board. So it really does lead me to believe that perhaps someone socketed this stuff after the fact. And look at the date code here, 1984 36th week, 84 23rd week, but that's in a socket. MMU, 1984 49th week, 84 39th week, 83 33rd week, that's the pokey, that is soldered onto the board. 84 48th week, another soldered IC. 83 31 in a socket. This one have an actual date code, I guess, 42nd week of 1984. 46th week of 1984. 87 30th. So it does seem like someone swapped these out. Maybe originally it had these MOSTech chips. 84 53rd week. That matches the rest of the chips on the board, but these do not. Interesting. Well, let's give this a power cycle now that I've re-socketed all the chips or taken them out, put them back in. Maybe that's all it was. Nope. So what's kind of difficult in this situation is we saw normal activity on all the address bus lines, all the data bus lines. Nothing looked stuck. It didn't look like the CPU was stuck. Just seems like this machine is not working. So I have nothing to go on when it comes to trying to figure out what's wrong with this. We could have a problem with the ROM chip. We could have problems with the custom chips. There could be a logic IC that's failed, causes this black screen. It's really hard to say at this point. So I'm going to bust out the Retro Chip Tester Pro so we can at least try to rule out the two ROM chips just to make sure that those are not the issue. So I was going to start with the basic ROM. And definitely this was desoldered from the board. Yep, this has been removed at some point. Just need to straighten out the legs a little bit. They're a little cattywampus. I've used that term a few times in this video already. Okay, so this is a 2364 because it's an 8K ROM and it's a 24-pin variety. There are two versions, a 28-pin and a 24. I don't know how it should be selected, so hopefully there's an auto detect. Yes, there is. When the chip select line is low, that means this chip is selected. Let's see what this reads as. There we go. That's exactly what it is. 600XL ROM. I guess it's the same in the 800XL and the 600XL. That is the matching part number though. And the other ROM I read was the same footprint as the 27128, which I think matches the 23128. So we'll try it this way first. I'm assuming it's going to be this way with low, low, high. Let's just try that. It is reading it. Those boxes would have like empty pixels in them if this wasn't reading. Okay, 130XE. I think the XE uses the same ROM chip as the 800XL. This has a 1983 date code. So that means that it's definitely not from the era when the 130XE existed. It was later than that. All right, well, I'm going to put dots on these just to say that I've tested them and they appear to be good. So RAM is good, that's good. The first chip we could easily test is the Sally CPU, since I happen to have one in this little bag of parts. I also have an Antic and a Pokey, but this is an NTSC Antic, and I'm pretty sure it's not compatible with this one. Well, let's try this untested Sally that I had in my spare parts bin. See if this makes any difference. I assume we're gonna get a black screen now. Yes, we are getting a black screen. Okay, so I don't think the CPU is the culprit. So I think the next thing I want to check before I desolder anything from this board is there is a 74LS138 that's generating the chip select lines for the PIA, Pokey, GTA, and whatever CCTL is. Not sure what that is. The rest of those lines are not connected to anything. And then there's another cascade line that goes to the MMU, which looks like it generates some additional signals, which we may need to take a look at just to check the outputs of this chip. I'm really not familiar with how failure prone any of these Atari chips are, so I don't know if this MMU is something that can fail or regularly fails or is never fails. Now this 74LS74 is used for generating clocks. I don't think we need to even worry about that. I think there is no issue there, so we ignore that chip. And then the Atari uses a 4050 to combine the variance luminance outputs from the GTIA and the composite sync signal. Don't think there's an issue with those, so we can ignore that as well. We're getting a seemingly good video signal with just nothing in it. I think we wouldn't have even gotten that brown screen we saw when I took the ROM out if that chip were bad. And this stuff here for the color is probably all working because we had working color as well. And we can ignore all of this audio stuff. LM358, those op amps should be on here somewhere. It's probably this little small IC. And then there's a bunch of RAM muxes, 74LS158. I think that's what that is. Yes, it is. So this is creating the address lines for the RAM. We might want to scope the output of these just to make sure that all looks good. And a 74LS375, that chip is in a socket there. That might be worth looking at as well. And then we can probably take a look at the CAS and the RAS lines, since those are going through all these logic gates. And there's a delay line, that's this right here on the board. That's going to be used for RAS and CAS. So we should scope the RAS and CAS, scope the WRT line, and then we should look at these multiplexed address lines. And we can find all of those on the RAM chips. Yeah, there's a RAM chip, and those are all the signals we're looking to scope. It definitely can happen on the Commodore 64 that the muxes go bad for the RAM, and that can break the system entirely. Okay, turning on the system, pin 1, refresh. Hooked up to 5 volts. I don't know what that signal even is used for, but it is high all the time, which is what it should be. Pin 2, data bus lines. I'm just going to go through pin 2 on all the chips real quick. Just make sure that they all look good. All of these chips share all the other signals between them, RAS, CAS, and the address lines. So I just want to make sure that the data lines are routed correctly to them. We don't have like a broken trace on the board. So everything so far, so good. Yep, that's good. And the top chip, yep. Okay, data lines look good on all of them. Okay, pin 3 is the right line. This is shared between all the chips. Looks good. 4 is RAS. That's what I would expect to see, something like that. Pin 5, multiplex address line 0, looks good. Okay, so I'm on pin 6, multiplex address line 2. That doesn't look right. Let's look at the next pin. That has activity. Back to pin 6 is dead. Now remember what we had talked about in the last Atari repair video. You should always turn the power off and on and make sure you don't see activity when you power back on. No, we do not. That's a smoking gun there, everyone, I think. Let's quickly check the rest of these. This is pin 7. 8 is just VCC, so that looks good. We're on pin 9, multiplex address line 7. I mean, they're not really in order, but that's just the way, I guess, Atari did it. This is pin 10, multiplex address line 5, looks good. 11, multiplex address line 4, also looks good. Pin 12, multiplex address line 3, that looks good. Pin 13, multiplexed address line 6, also looks good. And then we have pin 14, which is just tied to pin 2, so those look good, obviously. And there's CAS, and I'd say that looks fine as well. In fact, if we turn the system off and on, you're going to see some different activity for a split second. Yep, and it changes. Cool. Okay, everything looks fine except for this one address line. Now let me find it again. There it is. So this is pin 6, multiplexed address line 2. Let's check pin 6 on all of the chips. Oh, wait a second. Wait a second. Oh, okay. So on this bottom chip, it looks like that. On the chip above it, it looks like that. Looks fine. And I'll just go through and check them all. I think there's a broken trace. Yep. That looks fine. That looks fine. That looks good as well. That looks fine. And that's it. I think this is a bad trace. There's no way it would only be bad for this bottom chip and not the rest. It's paralleled, all of those lines. I can easily test with the multimeter. We're in continuity mode. I will check that pin between 2 of the other random chips. Okay, we have good continuity. And then to the bottom chip, no continuity. Wow. So I wonder if someone socketed this stuff at some point and the machine never worked correctly. That looks not the best. So let's see. It would be that pin to that pin. No connection. But from there to there, we have a connection. We have a connection there. Connection there. That's short. No, that's just the flux. There, 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 and there. It's just missing right there. Bodge wire required. Okay, a little bodge wire has been fitted. Just make sure that I haven't shorted anything. So it is connected. It's not connected to any of the adjoining pins. That's what's important. You know, I've caused issues in the past with that. Just the power is connected to it. Let's check the address line on the chip up here. Looks fine. And let's check the address pin there. And that looks fine now as well. So we don't have any bad pins. That looks good. Yeah, they all look good now. So let's give this thing a test and hook up the video. See what we get. Come on. Have it be the only problem. Look at that. That was it. That was the only issue. Let's just dial in the color. Where's my little screwdriver? I think this is the delay circuit here, so we can just get that dialed in. Much better. Oh yeah, so no bad chips, which is good because I don't have a spare PAL Antic or GTIA. I only have one spare Antic, and it's the NTSC variant. So I'm glad this machine worked. It just needed that one bodge wire, and I wasted a bunch of time by testing these chips out of the board, which I really didn't need to do. I should have just probed around and looked for bad connections because we know rework was done. And anytime there's rework, you gotta inspect a little more closely. All right, let's start with Ms. Pac-Man. Let's see if Ms. Pac-Man fires up. I can't start it without the keyboard connected, but at least we'll see the splash screen. And we do. That's cool. Let's pop in the Super Salt cartridge. Make sure I plug it in the right way, backwards. I also can't do anything with this without the keyboard connected. But, oh, sweet, it looks good. That color looks way off. Although I kind of remember reading now that the color on the PAL machines is quite different than the NTSC ones. And I assume I made it worse by turning this potentiometer. I think this potentiometer is kind of dying, actually, because it goes black and white. Let me get some contact cleaner on there. Okay, I put a little bit of Deoxit on there, and I'm turning it with this little ceramic tool as well. All right, maybe this is actually not a problem. This could be that it's just the PAL color decoding on my RetroTink. Yeah, I think it's fine. I don't think it's dirty. Okay, well, I'm going to plug in this filthy keyboard here and see if we can type some stuff. I don't have a lot of confidence in this ribbon cable. It looks horrific and all bent up. Obviously, because this is a PCB-based keyboard, you could replace this with wires, which might be something that needs to happen because this looks bad. This ribbon cable is definitely pulling apart, but I think I have it in there all the way. Okay, cool. So that worked at least. I'm going to do gray color. This is how I adjusted the color on the NTSC model. I turned the potentiometer. Yeah, like this can't be right where there's like weird rainbow colors like that. See the gray line that's right there where my finger is? And then right underneath it's kind of an orangey brown color. I think that at the bottom, which I can't point to, I think the gray line that's down there and the orangey brown color should be the same. See, I don't think it really matches right now. It's not smooth. The gradations. I think the gradations should be relatively smooth. Maybe I'm adjusting this incorrectly, but I feel like the way it's looking there, right there, it looks like it's a good rainbow pattern and it seems to repeat properly. But people did comment in the comment section on the test video that the PAL machines do have different color and games written for NTSC won't look correct with the colors at least when played on PAL machines or vice versa. Okay, I just popped out the cartridge and I'm going to hold down, I think it's select. I can never remember. One of these will disable basic and it will launch the diagnostics. And my fingers are all dirty again. That was not it. So let's try option. There we go. That was it. So let's do a memory test. So we hit start and let this run through. Now the nice thing about this test is it actually tests the MMU, so it's able to access all 64 kilobytes of RAM. Some of that is bank switch, so this is a really good test to just make sure all your RAM is working. I don't know how good of a test it is. Has anyone ever disassembled the ROM to see what type of RAM test it's doing? I'm assuming it's not like a March test, so that would be nice to have a much more thorough RAM test for the Atari. I mean, honestly, it'd be good to have a dev test ROM you could put into the XLs right on the motherboard that would be able to initialize the video without using a stack or zero page, so we wouldn't have to rely on RAM. Because entirely this was a RAM problem, clearly, and the Super Salt cartridge wouldn't start with that missing multiplex address line on that one RAM chip, which is really unfortunate because it just really means that this is not very useful of a diagnostic, at least not for detecting black screen causing issues like this machine had. And there we have it. All the RAM is good. It just loops, so you can actually let this run into a sort of a stress test if you want, but one pass is good. ROMs and RAMs are good. Let's do audio visual test. I want to hear those pokey sounds. Bit more of a delay than I would like. Where's the 8-bit dance party on this thing? One more channel and then we know this is a good chip. Oh yeah, that's a working pokey. The select key is pretty jittery. Okay, let's do a quick keyboard test. Okay, with the keyboard test, we do have some bad keys. The dash key is bad. U, M, Z is kind of flaky. Now it's not working at all. It was working a second ago. And the left shift key does not work. Everything else works except select is kind of sketchy. See, it's very jittery. So that's messed up as well. Now, unfortunately, fixing keyboards is a little bit beyond the scope of this video and frankly, something I absolutely loathe doing. And this keyboard's weird in that I can't get the keycaps off. So I'm thinking that I might just take the whole keyboard off as is and throw it into an ultrasonic cleaner complete and just let it work at it, clean the grime, and maybe that'll fix up the bad key contacts. I don't feel comfortable ripping the keycaps off. I mean, I don't get why some of them are so twisted. Like, look at this and that. But I'm also scared that if I pull too hard, it's just gonna break the switch and then there's no way this thing is ever gonna work. Before we do that, we're gonna try playing a few games and I'm gonna use this, my A8PicoCart. So a Raspberry Pi Pico and a simple PCB carrier, and that is it. And if you can believe it, this is a functional multicart for Atari systems. Powering this on, we get the menu, and I do have a PAL directory here. What is in this exactly? Oh, I have a couple games that are PAL versions. Let's try one. Well, that didn't work. I haven't tested all this stuff before on any other working Atari, so let's try something else. How about Computer War? It sounds so out of tune and horrible. Computer War, copyright 1983, Thorn EMI video. Press start to play. All right, DEFCON 5. Okay, well, obviously we have a war game sort of thing here. All right, I don't know what to do. I have no manual for this. It's a pretty fancy game, to be honest. No enemy missiles. Is that a missile up here? Oh, yeah. What am I supposed to do here? I am completely lost. Okay, we're gonna try something else. Now, the funny thing about this cartridge is you have to reset it first before you hit reset on the console or on the computer, because if you just hit reset on the computer, it will reboot right back into the game you were just in. All right, let's try River Rescue. Let's put the sound on. I kind of assume that box that says S, oh, there, the game started, is the start button. Oops, that was quick death. Whoa. Oh, come on, I'm terrible at this, terrible. Now you have to remember, by the way, before you criticize my playing too much, I'm playing through video capture. It's so laggy compared to having this hooked up to a TV directly. So you have to kind of excuse the terrible performance of any playing I'm doing. Yeah, basically when you push the D-pad, the response time is terrible. I think there's like a second of lag or more. So, okay, well, that game is unplayable with all the lag, at least. That's what I'm going to say, at least. So we'll reset the cartridge. Causes the computer to crash. I have to hit reset, and that'll bring us back to the menu. Let's try Archon. This is a 1987 US ROM. Hey, it works right off the bat. Now, whether the music's right or what, I couldn't tell you. Press any key to continue. Yep. Oops, dropped my little tool. That's Archon, all right. I have to imagine the colors are maybe off a little bit. Oh, by the way, I installed some of these other salt cartridges on here. And some of them seem to be a bit more fancy than the one we were using. I guess this one is designed for the Atari 65 or 130XE. And there's the CPS Super Salt, which I think is different again. Yeah, copyright 1900, Irata Inc. Press break for menu. So again, very similar test to the one we had before. Select to move pointer. So these are the individual tests. And a lot of these tests seem like they're the same ones that were in the Super Salt test. So I wonder if these folks wrote this diagnostic for Atari maybe? So if we do C for color bars, that's just like a larger version of those same color bars we had in the other test. And then this has some other GTIA diagnostics and stress test options, things like that. I'm sure this thing will pass all of its tests. Those games wouldn't have worked properly if things weren't working properly on this machine. There's an antic stress test on here. Looks a little bit different than the one from the Atari cartridge, but I guess whatever this doing is like really stressing out the antic, which is good to show if there's any issues on it. But anyways, it is detecting this as an XL 64K machine, which is correct. Okay, here is the last V8. Hit trigger to start. V8, return to base. I never knew, I was gonna say, I never really knew how to play this game very well. I just immediately crashed. How do you turn around corners? Oh, you can go backwards. Oh, is that base? I guess that's not base. This game was also on the 64, and I know lots of folks liked it. The base is 4 kilometers away. So I guess you need to slow down. Oh, I'm telling you, I'm trying to steer. I wonder if there's a problem with the joystick where I can't go down. Oh no, you can. I just don't know how to play this game. Whoa, no. I'm so bad at this. And I can't use the lag as an excuse with this. Because a game like this, doesn't... Yeah, I don't think lag is really an issue here. I think it's player, it's user error, I mean. Okay, here we go. Whoa, I was going way too fast. I should have slowed down. Okay, here's a Polish game called IQ Master from 1992. Let's see if this runs on this machine. I'm sure this game, being Polish, was designed to run on PAL machines, which this is. Okay, 1992 by ASF. Can't read Polish, I don't know what that says. Is this some kind of a like Tetris type game, but with letters? IQ Master, right, so this is some kind of a puzzle game. I couldn't tell you what I'm supposed to do here. Okay. I still don't get it. Are we supposed to spell stuff? I'm assuming we're supposed to spell things. And I got lucked out with whatever I did, those letters disappeared. Hey, it works. So that's something. All right, that is going to be it for the repair on this Atari 800XL. As per usual, these are reliable machines. The only fault this thing has was caused by a user or a technician or whoever it was who was socketing those RAM chips and caused that bad trace. And I really do wonder if someone did the work to try to fix this computer, like maybe they socketed the RAM because it was bad, and then they caused this issue and they never got the computer to work again. There is lots of wear on the keyboard, so I could tell that this thing was used. But judging by the fact those RAM chips were from 87, maybe the RAM failed around 87 after this thing had been used for a number of years, and someone tried to fix it, were unsuccessful, and maybe they socketed the other chips in the process of trying to solve the issue, like they thought there was something else wrong. But it all goes back to what I always talk about. If you're not really skilled with desoldering ICs from boards, it can be really easy to cause damage that's hidden like that. And in the case of this machine, I'm assuming it was never found and the machine never worked again. So there we have it. If you enjoyed this video, I'd appreciate a thumbs up. But if you didn't, you know exactly what to do. Huge thanks to my supporters. Names are going up the side of the screen to make it possible to do this full time on all the usual YouTube junk. Comment down below, subscribe, etc., etc., etc. And I hope people have been enjoying this Atari content. It's been kind of fun to work on something different for once, but I think I'm out of broken Ataris, so that means I'm going to be working on some other stuff. So that's going to be that. Stay healthy, stay safe, and I'll see you next time. Bye-bye.